Okay, I hope you got those answers right about the product rule, which involved the chain rule also. Now the last one for you is quotient rule. And that ends the story for the various techniques we are learning. And these would be good enough. The product rule, the quotient rule and the chain rule would be good enough for us to solve the questions what we are going to face in the early days of class 11. And later on, when you go in for deeper math, then obviously you'll learn a lot more in differentiation to be able to do much tougher questions. But here again, we are confining ourselves to what may come in physics and chemistry, what may be required. So quotient rule is, as the name suggests, if you have something by something, like instead of a x into sine x d of this, what if the question was, what is, instead of this, what if the question was d of sine x by x? Now suppose I haven't taught you quotient rule, that is something by something. How would you do that? How would you do that? Can anybody do that? Pause the video. With the rules taught till now, try to do that. Sin x by x. Okay, I hope you got it. We'll make do with what we know and we'll keep our math intact. So what is this? D of 1 by x into sin x. And I can treat it as product rule. So product rule is good enough. So this quotient rule is an extra add-on only, just to make your calculations a bit faster. So these are the two functions. First you can take 1 by x outside and differentiate sin x, which will give you cos x. And next you can take sin x outside and differentiate x 1 by x. So what is differentiation of 1 by x? 1 by x is x power minus 1 by dx. What is the differentiation of that? That minus 1 comes in front and the power goes down by 1. So it is minus 1 x power minus 2. So you'll have minus of x square multiplied over here. Minus 2, sorry. So if you want to write it in a more pretty way, this was your cos x, and then you have a minus over here, so minus sin x, and you have a x power minus 2, so that x square is at the bottom, and you want to make the LCM. This was 1 by x at the bottom. You can have it as x square at the bottom and x over here to have the LCM same. So this guy and that one has the same LCM, has the same denominator. And it looks like this, right? So have we used any quotient rule yet? No, we haven't. So in the same spirit, I hope you get this. Pause the video, see again if you don't get this. If the question was d of, say, u by v, instead of u into v, u by v, okay, by dx. Using the same technique, can you get me the formula, what it will be? So hope you did this. What you did is, first take one of the functions out and differentiate the other one, and then the other function out and differentiate the first one. Say first I take 1 by v out and differentiate u, so it will be du by dx. Mind you, this is rewritten as, to apply the product rule, 1 by v into u by dx, and we are applying the product rule. So 1 by v out and differentiation of u, then plus u out and differentiation, I'll write over here a bit, differentiation of 1 by v by dx, right? Now 1 by v by dx, I can apply a chain rule over here. I'll do that over here so that this doesn't become long. D of 1 by v is d power v minus 1 by dx, but we wish it was by dv. So if I put my wish over here, I'll remove the wish and put x back. So what do we get? V power minus 1. I just did it somewhere over here. X power minus 1. What do we get? Minus 1 comes in front, and then v power minus 2. So it is a negative 1 by v square. A negative 1 by v square. Minus 1 in front and v power minus 2. V power minus 2 is 1 by v square. And then dv by dx. So this thing is that thing. Pause the video, have a look if you have a doubt. If you don't, then continue watching. So that's equal to 1 by v du by dx, and then u and the thing what we found out. So we had a negative over here, so instead of plus I'll add a minus. That minus comes. There is a u, from the original one, and there is a v square, v square, and dv by dx. So yes, there is a du by dx, there is a dv by dx. If you know the function, then you can differentiate that function. Now you can take the LCM as v square and write it in a more pretty way. So I'll write it straight away over there because that's the final answer. So it is v square as the LCM, the one which was in the denominator, the square of that as a common denominator for the two parts. And this time what we have got is a v du by dx as previous time, and a u dv by dx, by v square by v square. A v du by dx by v square, we have taken v square, we have taken a v square and a v over there, v square and a v, so that's 1 by v. So we have this v du by dx as in the product rule and a u dv by dx, but there is a subtraction this time. It's a minus, so the order matters. Last time any which one was in front, this time the order is going to matter. The one in the numerator, watch very carefully, the one in the numerator has to be differentiated first. Get the point? The one in the numerator has to be differentiated first. The one in the denominator is squared in the denominator. The function in the denominator is the one which is getting squared. So be careful over there. And now if you know the rule, then instead of doing these two steps, this one could have been done faster. So maybe here, maybe this will be enough space to demonstrate that. So what is that? Going by the rule, first is take the denominator function outside, take v out, denominator function outside, x is outside, differentiate sin x. So differentiation of sin x is cos x, differentiate the numerator, minus take the numerator outside, which is sin x, and differentiate the denominator. Numerator outside, differentiate the denominator, which is 1. Differentiation of x is 1, divided by the square of the denominator, which is x square, square of the denominator. So what you get is, you get the same answer as this one, but much faster, because whatever you are doing to get it, you have done it for a general function and made a rule for yourself. So for yourself, you have created a rule so that you can do stuff faster. So this is just to do stuff faster. So that's your quotient rule. So again, we'll be giving you a bunch of questions on quotient rule and try to find out those answers. And I really hope that we don't have to discuss the answers and you get all of them right. Okay. So that's it, guys. Now just tell me, with these rules, are you good enough to find out few more differentiations, like say tan x by dx, say sec x by dx, say cosec x by dx, won't be used that much, tan x might be, but with these, can you find with the rules what you have done, and only 4 of them given. Now can you do a tan x? Can you do a tan x? Yes, we can. Tan x is sin x by cos x. So we can apply quotient rule and we can do a tan x. So do these cot x you can do separately, d of cot x by dx. That would be a good practice of quotient rule for you. So I hope you don't get it wrong. Remember, product rule is quite easy to remember. Quotient rule, sometimes the kids forget what was to be differentiated first. The numerator has to be differentiated first, and then the denominator, in the same way as the product rule, but there is a minus in between. So numerator and then denominator, the order matters, and in the bottom the denominator square happens. Get the point? Is it clear? Try to remember this. Try to remember this. Otherwise, I told you how this has been derived. So if you are actually forgetting in a test, you can quickly derive it, or simply use the product rule, which people generally don't forget, to find out the answer. So that's it for the techniques. Thank you very much. We'll have a test on this. That's the bad news, but practice it a lot, and these are really easy and fun to use. So that's the good news. Okay, bye bye.